Hi guys, welcome to the third video on the inequality and equation series. I'll be looking at I'll be using this textbook. It's a online textbook. It's Siavula. I'll be looking at this textbook for this part of the work, but I really, as I said, I'll be changing resources so that you really get a mix of everything, and a feel of everything. So now, even if you didn't know that this textbook is available online, you can Google it and you can find it online. There's a lot of stuff that they talk about, right? You can sort of like pick up the book and read it and look at what is important. Suppose someone says solve the following equations, right? Really just evaluate these expressions. I think that would have been a better question. So that would be 0. And if you think about what makes it 0, it's this 0 over there. So everything over here would be 0, right? Not really everything. Yeah, everything until number 3. But I want us to interrogate what's happening at 4. At 4, we have 7 times something that we do not know. And the answer that we are getting is 0. What must be the value of that something? Turns out from what's happening here, we can clearly see that must be 0. Or if you can't see that, then the only time you can get 0, it's when you're multiplying something with something that is 0. So 7 is obviously not 0, so this business over there must be 0. So we can come here and be like, we're multiplying two things, and one of them is 0. Right, so we're multiplying two things and they're equal to 0. One of them must be 0. It is clear that m would have to be 0. Number 2, we're multiplying 3 things and the answer is 0. So one of them must be 0. The x has to be 0. But guys, this brings us to this guy. We're multiplying two things and that idea must stay there, that one of those two things must be 0. Either k plus 3 must be 0 or k minus 4 must be 0. Right? In this case, we didn't say either 6 must be 0 or m must be 0 because 6 is a value. So we know that 6 is not 0. Right? So really, this idea that is being brought here is that thing that we always say, take this and set it equal to 0, take that and set it equal to 0. It really comes from here. Now, first of all, here we'll be looking at solving equations using factors, right? So let's see. So this is the method of solving quadratic equations. You write the equation in the standard form. So if you have something over on the right hand side of the equation, bring it back, put it in the standard form and make sure that it's in a standard form. And it says divide the entire equation by any common factor of the coefficients to obtain a simpler equation of the form ax squared plus bx plus c is equal to 0, where a plus b have no factors. So you put that, so you can see a, b, and c have no factors. So you've divided up to a point whereby you can reach this form, but a, b, and c have no common factor among themselves. But I want to remind you that I've said we don't divide, right, in an expression. But this is not an expression. This is an equation we can divide. But that goes with a rule, right? You can, if you divide, you must divide both sides. You must divide the left-hand side and the right-hand side. So whatever that you do in an equation, you must do it both sides of the equation. Right? So in an equation you can divide, but in an expression you cannot divide, right? So you can factorize that business to something like that. If you factorize it to something like that, that must be 0 and that must be 0 like that, and because of the ideas that we've sort of like discussed above there, and then x would be that and x would be that, right? You take that to the other side, it becomes negative, you divide it by that u, becomes that value. Okay, are we happy with that? So we have our first example, right? And we'll be using factorization to solve this. So this question is already factorized for you. Sorry, I didn't say it's equal to 10. So what do you need to do? The first step is rewrite the equation in that form. So you multiply the x squared, you multiply the minus 3 over there, and you bring the 10 to the other side, right? So you expand the brackets and subtract 10 from both sides, right? X squared minus 3x minus 10 is equal to 0, right? And then you factorize that business, right? I'm not dealing with factorization perhaps in this video. If guys you really think you want me to help you with factorization, I will refer you to a separate video that I might be dealing with factorization. I don't have a video now on factorization, but later on I might make one if people are struggling with this. So now you have that, and we're just saying x plus 2 is equal to 0, or that business x minus 5 is equal to 0, and then we have solved it, right? We have solved it. And really, let's look at, I love this textbook, guys. You see, if we read our textbook, we can really get the essence of what's happening. Let's look at what are these values. If we were to plot this function, if we were to plot that function, this is what we were gonna get, right? And these over here are our roots. They are our roots, right? They are our solutions. So you can check this. You can check the solution by substituting both answers back into the original equation, and you can therefore write the final answer. Maybe you don't know why it's important to check at this point, but the examples that are to come, you're gonna see why it's important. So we have a second sort of like question. So we have 2x minus 5x minus 12, and we have to factorize that, and you can clearly see there's no common factor there. So, and it's already in that form. So you can simply go factorize. We must determine the combination of factors 2 and 12 that will give a middle term of the coefficient of 5, right? Again, that's just factorization. Yeah, I'm not gonna say much, but yeah, you find those factors and you find them and you plug there. You write them as factors like that. And therefore, the solutions would be, if you take that 0 and if you take that, make it 0. I hope you guys are still following. And then you can then find your roots. And it's still important to check. Maybe it's not clear why it's important to check yet. You can look at that. That's already in a right standard, so you can factorize, but you can clearly see that's a difference of 2 squares. You can take a difference of 2 squares if you want. Yeah. So doesn't look like a 7 is a square, but you can force it to be a square, and that's really how you do it. You say, if this would be a square, this is what would have to happen. You know, I would just take a square root of 7 and then square the thing. Then what is inside the whole, what is outside is a perfect square now, right? And then you can take the difference of 2 squares. You can set that bracket to 0, set that bracket to 0. You'll find your solutions, right? So if you were to draw that function, that would be that function. And so the square root of 7 would be the negative. So you have 2 roots there, you have plus minus, so the negative one would be there and the positive one would be there, really. Okay, now we are in example number 4, solving quadratic equation using factorization, which is what we've been doing. So you look at this business and you look at it, you're like, what's happening here? Remember guys, every time when you have fractions, you want to multiply with what is in the denominator, right? But the first step is to write your restrictions. You can't solve that equation if b is -2, and you can't solve that equation if b is -1. So you must first state your restrictions, that b may not be equal to -2 and b may not be equal to -1. I challenge you to think about why. I know it told you, wish you don't read, and you think about why you can't solve if that's the case. But nevertheless, even if they told you, but just think about it anyway. I need to check the time quickly. Mustn't go over the time. I'm almost over the time, so I'm gonna stop the video and I'll make the next video just now. Bye guys.